Okay, guys, in this video, we are going to continue analyzing data, but this time it's going to be quantitative discrete data. Remember that discrete data are numbers that are counts. They usually don't have any measurement units, and there will be values not on an interval, but actually something you can count, like 0, 1, 2, 3, 4, 5. Okay, now how do we analyze data like that? So here I have an example that we're going to look at. And we are asking 20 different households how many cars they own. And we got the following data. Now, I actually had a hard time copying and pasting this data. Usually what's going to happen in the question is the data is going to be hiding inside the button. So you're going to press a button, the data is going to show up, you're going to highlight it and copy paste it into Desmos. But in this case, I have it on my slides. So I just did that before starting to record the video. I copied that and pasted the data. Now, what you would need to do is you're going to need to type the name of the list you are pasting it in. Remember, we had like frequencies, but this time we're going to be using L for list. Okay, so you're going to be typing L equals, and then if your data is vertical, you're just going to highlight it, copy paste it, and it's going to paste into Desmos. If it's in horizontal format like this, then you actually have to add the square brackets so that the data is inside the bracket separated by a comma. Okay, now the data is in there. So what do I want to do? I want to count how many times I saw 0, how many times I see 1, and so on. So I want to get the frequencies. This time, sometimes they will give you the frequencies and just ask you to find relative frequencies. But sometimes you will have to find frequency first. So how do you do that? Well, there are two different ways. Actually, there's a third way, and that would be manually count how many times 0 happened. Well, I can see it looks like 3, but that's unreliable. You might make a mistake, and then everything is going to be wrong after that because you're going to miscount just one number, and it's going to affect everything else. So here are two suggestions. Suggestion number one, use the command sort. So if I put sort, then open parentheses and L. This gives me my list, but now it's sorted. So if I click on the 20 element listing, it'll show me how many times 0 happened, right? So it looks like it's 3. 1 happened 1, 2, 3, 4, 5 times. 2 happened 4, 5, 6, 7, 8 times. 3 happened once. 4 happens 2 times. 5 happens once. So that's pretty easy, right? So maybe that's something that you want to do. That would be perfectly fine. Now, on the slides here, I recommend the second method, which is also a pretty good method, I think. So you're going to have to just decide what's better. And the method is called histogram. What is a histogram? Histogram is a graphical representation of quantitative data that looks just like a bar graph. I mean, you're going to have these bars with the height equal to the frequency, so that's the same. The difference is that here the bars are going to be in a specific order because numbers would go something like 0, 1, 2, 3, 4, and so on. So you can't switch the bars around. Unlike qualitative data, you don't have to put Ford first and then Chevy and then whatever, right? Here it has to be in a specific order. So we can talk about actually shapes of histograms, which we're going to do pretty soon. And also the other thing that's different is the bars touch each other. So there is no gap between bars. And that would be visually how you can tell that the histogram is different from a bar graph. All right, so how do we do it in Desmos? Very simple. The command is histogram. Okay, so a lot of stuff in Desmos is very intuitive. So you just put histogram L and it gives you this little tiny histogram. Now, if you want to actually see it better, here's what you want. You want to scroll, right? I mean, not scroll, use the mouse and position it right here. Okay, this is called zoom fit. I don't know why Desmos doesn't by default do that, but you're going to just have to click on that. And that allows you to see the picture better. So you can just read the heights of each bar, right? So it'd be like 3. We already did that. So we can tell that there was 3 and then 3 zeros. And we said it was 5 ones. And we got 8 twos and 1 3 and 2 4s and 1 5. So that's another way you can do it. Now, there is one other thing I wanted to show you, and that is these two double arrows in Desmos. So this right here, that actually hides the left-hand side, which is like the expression or the commands that you type. So if you click on that, ooh, now my histogram is really large. Okay, so that maybe it'll be easier to tell the height so you can answer the questions. Okay, so that's how we do it. We don't change anything else here. So the bar height should be counts and the bin alignment should be center. So each bar is centered at the integer value like 0, 1, 2, 3, 4, 5, and so on. Okay, now based on that, how are we going to get the relative frequencies? Well, the same exact way as we did before, except now we had an extra step of actually finding frequencies first. But once we find them, and we already know what they are, we're going to type them in F. So that's the second stage here. We're going to say, okay, well, we have 3, right? And we have 5 and 8, 1, 2, 1. And then just like we did before, we're going to type F divided by total F. That gives me relative frequencies. If I want to round them, in case I do need to, I would insert the command round, open parentheses. Then remember how I click after the fraction, I put comma and 3. And that will give me my relative frequencies. Okay, so that's our frequency and relative frequency. Now let's answer some questions. First question, what proportion of households have 2 cars? Well, that's very simple because we can tell that the relative frequency and proportion are exactly the same thing. And corresponding to 2 cars, we've got 0.4. So the answer is 0.4. Okay, very simple. Now, if it says what percentage have at least 2 cars? Now, what is that? Percentage has at least 2 cars. So first of all, what is at least? So this is something that you're going to need to put on your note card. So I don't know if you know this, but you will be allowed to use only one 3 by 5, 3 inches by 5 inches note card on a test. You can use front and back, but you can use nothing else. You cannot use a sheet of paper or a notebook. No, you have to have a 3 by 5 index card if you want to use it. And on the index card, I recommend putting what is at least 2. So at least 2 means 2 or more. What that means is you're going to take all relative frequencies starting at 2. This is a very common mistake. People think that 2 is not included. Note the difference between at least 2 and more than 2. If it's at least 2, it's 2, 3, 4, 5. But if they said more than 2, then 2 would not be included. So it's just going to be 3, 4, and 5. Okay? So you would just add them up. So you would go and add 0.4, 0.05, 0.1, 0.05. Now that's 0.6. And if it were proportion, that would be your answer. But because it said percentage, you would have to multiply this by 100. And that's going to be 60. Okay, so that will be your answer. So that would be 60% of households own at least 2 cars. Finally, if it says what percentage of households have at most 2 cars? Now, at most 2 cars, S is missing, I need to fix this. Oops. Cars. Okay. So what does that mean at most 2? At most 2 is 2 or less. So this means that we're going to be highlighting the relative frequencies at 2, 1, or 0 and adding them up. Okay, so let's go ahead and do that. Again, at most 2 also includes 2. Compare that with less than 2. If they said less than 2, that would only be 0 and 1. But if it says at most 2, then 2 is also included. Okay, so that gives me 0.8, and then if I need to convert that to a percent, I would multiply that by 100, and that would be 80%.